All right, welcome back. So here's the last video for our lab. All right. So what we've done so far is we've created these two graphs, displacement versus time and velocity versus time. This one was just graphed with the data that we collected during the lab. So the displacement versus time just came from the data. And then this velocity versus time, remember, we did a calculation for the velocity and graphed those ones versus time. All right. So what do we do with these things now? Well, both of these are actually giving us values for our acceleration. All right. And this is where we have to be careful. We have two different values for acceleration here. So what do we do with them? So we're going to take our two equations from our graph. All right. So we have the displacement versus time graph. All right. And our equation looked something like this. It's like y equals 1.29 plus a negative 0.671x plus 1.07x squared. And we said that this went right along with this equation, x equals x naught plus v naught delta t plus 1/2 a delta t squared, right? So these two equations match. And then we had our velocity versus time graph, and it gave us this equation, y equals 2x plus 0.0323. All right. And we said that this one matches this equation, v is equal to v naught plus a delta t. I know I switched that around a little bit, but that's because what's matching here with all of our x's are actually times. So every time we see an x, it matches with a t. So x squared, t squared, x, and delta t. Same thing down here. These guys match. All right. So I just rearranged it a little bit to help us out. So we're using these graphs to get our values for our accelerations. From this graph right here, our acceleration is what's in front of our t squared term. And we said that the 1.07 isn't the acceleration, it's half of the acceleration. So to find our acceleration, we know that 1.07 is equal to 1/2 of a. So that means we would just multiply it by 2, and that's going to give us 2.14 meters per second squared for our acceleration. Over here for the velocity versus time graph, all right, the acceleration is really just the slope of this graph. So this one doesn't involve any kind of calculation. It's just that the acceleration is equal to 2 meters per second squared. But this is the same marble. So we have two different accelerations for the same marble. But that's because we use two different methods to get those accelerations. We use two different graphs. So what we want to do now is compare these two values to each other to see how far apart they really are. All right. So we're going to do what we call a percent difference calculation. Now that we have our two accelerations, we're going to find how far apart are they from one another. So how does percent difference work? Percent difference works by comparing the two values together. So we have two values, value 1 and value 2, and we're going to subtract those. And then what we're going to do is divide by the average value. So the average of those two numbers, and then we'll multiply it by 100 to get a percentage. So the two values that we had, all right, the first acceleration, 2.14 meters per second squared, and the second acceleration, 2 meters per second squared, are the two values that we're comparing, all right? So we're going to plug those things into this equation. So A1 is 2.14 meters per second squared. A2 is 2 meters per second squared, and those are the top two values. The bottom value is going to be the average of those two. So how do you find an average? Well, you add them up and divide by 2, which should give us 2.07 meters per second squared as an average. And then we'll multiply that by 100. All right. So what do we get whenever we plug all of this into our calculator? All right, so 2.14 minus 2, and then divide it by 2.07, and we then multiply that by 100, and we should get 6.76%. Now my data is made up, and I kind of expect your percent difference to be a little bit better than mine. In fact, my goal for you is to get 5% or less for your percent difference between these two values. If you're up around the 10 and even 15% range, then that probably means that your data is too scattered, and that means that your fits aren't precise enough. You probably could have done a better job collecting your data, all right? So I expect it to be a little bit better. If you're up in those high percentages, you're going to see a little deduction. So what's your final write-up going to look like? So it's going to look a lot like the last one. We're going to do the objective and the purpose, right? We'll do our materials. We'll do the procedure. All right, then we'll have a data table. All right, and that's your data table from your sheets. And then you have two graphs, right? So you have velocity versus, you have displacement versus time. And you have velocity versus time, right? Then with those, now you have calculations. So these are sample calculations. You're going to show one calculation. So you don't have to show them all. We had 30 data points when we calculated velocity, but you need to show one calculation for those final velocities that we ended up using in our velocity versus time graph. But then you also need to show your percent difference calculation. All right? So you should show two calculations. If you can't put these into a Google Sheet easily, then you can handwrite them. Sometimes it's a little easier with equations. Finally, you're going to write an interpretation. All right, and this goes just like the other interpretations that we had, only we have two graphs, so we have to include both of those things into the interpretation. And then also, we want to discuss the percent difference as part of our error. And then we also want to talk about sources of error. All right. So this graph is, this lab is a little bit longer for it to write up. Take your time and make sure that each of the parts are correct. And then finally, you do have to hand this in individually. So this is not a group hand in. Every individual has to hand one in. Please do not copy off of each other, because if I see people have the same things, then you both get zeros. All right. If you have any questions, make sure you shoot me emails and I'll try to respond to them. Otherwise, you can wait until next week and I'll help you out. Thank you.